Welcome to InContext, the podcast by Blindata, the cloud platform to build and to govern the full life cycle of the enterprise information architecture. I'm Jacopo, the product owner of Blindata, and in each episode, together with Andrea and Gabriele, we'll explore how to enrich data with context to make it easier to understand, use, and combine, unlocking its full potential. If you want to learn more about Blindata, head over to our website, blindata.io, or sign up for our newsletter to stay in the loop. Now, without further ado, let's jump into today's episode and discover together how context changes everything. Hello everyone, hi Gabriele and Andrea, and of course hello to everyone tuning in. I'm super happy to kick off this first episode of Blindata in Context, the Blindata podcast, and I hope it would be the last, but that is all up to us. So Andrea, do you want to tell us what's on the menu today?
Yes, because InContext is the podcast of Blindata, and Blindata is a cloud platform to manage the information architecture. I think that it's a good idea to start with the first episode talking about the information architecture. So what is the information architecture, why it is important, and what means to manage the full life cycle of the information architecture. So I think it's a good topic for our first episode.
Yes, perfect. And if I remember correctly, in the strategy team you lead in Quantica, you have two rules. The first one is that whoever proposes an idea becomes responsible for it. And the second one is that when you go out for lunch together, you can't order the same things on someone else ordered. So I won't ask you what you had for lunch today, but since you picked the topic, I'm afraid it's your responsibilities to get started. And so let me ask the first question for this podcast. And what is exactly an enterprise information architecture?
Okay, you remember well. And of course, the second rule is the most important one. When we go for lunch, everybody have to take something different. It's all about curiosity, innovation, and experimentation. What is the enterprise information architecture? So we can split the definition. It's three words: enterprise information architecture. Let's start from the last one. What is an architecture? According to Martin Fowler, in one of his papers, say that the architecture is all the important stuff, whatever they are, that is important to know to understand the system and its behavior. It's a simple definition, but for sure not a trivial one. And recently, I also listened Simon Worley say that an architecture is a manifestation of our principles. What's matter for us, what's important to know about the system. So it's an important part of the system. It's the part of the system that drive its behavior and its main characteristics. Just quoting a more concrete definition from TOGAF, the architecture is about the structure of the system, is a description, is a model of the structure, the important part of the structure. So the key components of the system, how they are related together, and what are the principles that drive the design and the evolution of this part of the system and its structure. So basically, this is what an architecture is. An information architecture is an architecture that describes the system that we put in place in order to manage our information asset and make them reusable and extract value from them. And it's an enterprise information architecture because it's not an architecture the way we manage the information just for a specific application or for a specific domain, but how we manage the information at the enterprise level. That's basically the definition. It's important to also have in mind that when we are talking about information architecture, we are talking about an architecture that usually is a multi-layered architecture. It's not only about data, because data by itself have not value. Data must be put in context in order to be meaningful and usable. So the information architecture, of course, is about how we manage the data, but it is only the foundational level. On top of this level, so on top of the data plane that describe in the architecture how we manage the data, there is the information plane that describe how we manage the metadata. Metadata is very important because metadata give a context to the data and turn the data into information that are meaningful and so usable. Just to make an example, if I say 35, it's a number, it's a data, it's something that I give to you from Latin word datum, something given. But of course, these have no meaning for you, no? It's a number, okay? You know that it's a number, probably is in the decimal system base, but you cannot do very much with this data because you have not the understanding of the meaning. But if I told you that 35 is a measure in Celsius degree of the temperature recorded today in Milan, you understand the meaning of the data. So you have added metadata and you have turned the data into information. This information is meaningful and you can use it. For example, to decide that it's a good day to go to the swimming pool instead of recording a podcast. Maybe that's what you can have as an insight of that. So this is not the end of the story. In the information architecture, usually we have another plane, a third plane on top of the information plane. It is the knowledge plane that basically categorizes the meaningful information and organize the meaningful information to also abstraction and conceptualization to describe the specific domains you are working in. No? So, for example, in our case is Blindata or Quantica, and for example, in the knowledge plane, we put information like the fact that in order to be paid, we must come to the work, and we have some holidays during the year. But today, all of us have not taken holidays, so even if 35 degrees, it's not a good idea to go to the swimming pool because we are supposed to work. So where the information layer let you put in the data into the context, understand the meaning of the data, the knowledge layer make possible to understand how to use the information purposeful in your context to achieve a specific outcome. Without the knowledge layer, you can only base your assumption and take your action according to common sense. Thank you to the knowledge layer, you can take action that have meaning in your specific working context to achieve the desired outcome. So this is not a short answer, it's quite long, but we have decided that in this podcast we have no limit of time, so take it as it is.
Yes, yeah. So you have designed a sort of pyramid for this enterprise information architecture. So we have 3 layers. At the bottom we have data, then we have in the information layer, which is metadata, and on the top we have the knowledge. And I think that before getting fancy with knowledge and metadata, we have to start with the actual data. So the next topic I ask Gabriele is what happens in the data plane. What do you see our customers are working on, and what are the main problems on managing data in 2025?
Yes, in many organizations today we still see legacy monolithic platform that tries to do everything in one single place. And this leads to an extreme fragmentation, as you know. So different teams that try to spin up their own data stores, copy the same raw data set into multiple silos, and also ownership is always unclear, and nobody is formally responsible, for example, for data quality. And you know, where there is no responsibility for data quality, there is no data quality. So it is always a mess with, for example, still records, missing fields, like also inconsistent schemas. So, you know.
Yes, and that also is one of the main critiques of the traditional data governance approaches that comes ex post, that the data is built and created and so on. But here we have Andrea that literally wrote a book on this topic, and is about managing data product. Now we are seeing many customers, many organizations that are trying to take a different approach. Some of them call it data mesh, some that just call it that they manage data as a product. So here we have one of the best experts to ask about this new trend that is coming day by day more and more actual.
Yes, too kind. Yes, we see as a response to the problem that Gabriele mentioned that are quite popular in our customer. We see more and more an adoption of a paradigm based on managing that as a product. So basically, the idea behind it is quite simple. The monolithic structure, the monolithic application that manage data like data lake or big data warehouse became in a very short time too much complex to be managed. Tactics that the human can use when a system became too complex for our cognitive capabilities to split it down in a smaller part and manage the different part in an autonomous way. No, and this part within the data architecture is a unit of modularization and management of the data architecture is the data product. The data product solves or aims to solve a lot of the problem that Gabriele have described. So have a smaller unit, simpler to manage with a clear ownership in which the responsibility on data quality on the team that developed the product, and the product is designed to be valuable for the user. It's not just something that is about storing data in a big repository that grow without limitation in complexity. So we see that there are something moving in the field of data management, and there is some hope. So the scenario, the terrific scenario that Gabriele have described, we are trying to get in better, of course, copying good ideas on managing complex systems that come from other field of engineering and
so that depicts what is happening on the data layer. So we are trying we are trying as a community, I would say, to put into place better operating model than the one we had in the previous years. And we need also to move a layer up. And if from one perspective we have data, we have also metadata. That's the topic that we love most as a data governance platform. And so the question here is for Gabriele: what are the difference between managing metadata and data, and if there are some common problems as well as some different ones?
Yes, believe it or not, metadata often suffer even more than the data itself. This is because the data and metadata are completely misaligned because they have two different life cycles. On one end, you have data that with operational teams that own the raw data sets, and on the other end, you have a separate governance team that try to maintain a data catalog. They rarely coordinate, so the data catalog end up full of outdated schemas, like missing description, sometimes broken lineage, and so on. The result is that the user of the data catalog stop trust the data catalog and use it. So it becomes a...
And that I think that it is always the same problem. It's a problem of accountability, and it's a problem of distributing the right responsibilities to the right team or person that does the job. And also in this context, in the managing that as a product, we are trying to solve this problem. We're starting to hear more and more this idea of shift left, and the shifting left in less responsibilities, so that the metadata management aspects are designed and integrated during the life cycle of the creation of the data product. So Andrea, can you explain us what does it mean, the shifting left responsibilities in this context?
Yes, exactly mean what you are expecting that it means. No, it means shift the responsibility left more close to the source. In this case, we are talking about the responsibility and accountability on metadata, and shifting it left means that the teams and the people that create the data and expose the data in a production environment have the accountability not only on the exposed data, but also on all the metadata that contextualize this data and describe this data and make this data usable. So providing all the metadata compiled together with the data, it's a requirement. It's part of the definition of the activity of data management. It's not possible to move in production a data set or a data product if it not come together with all the metadata that are required by the global governance policies. This is the shift left. It's not anymore a downstream team of data stewards that manage the metadata and create the metadata after the data product or the data set has been published in a production environment, but this part is created by design in the process of development, the data set and the data product, and it's something that is not possible not compile if you want to move your data set to your data product in a production environment. This is a very important thing because synchronize the life cycle of data and metadata and put the accountability on data and metadata on the same person, on the same team. So Gabriele always described a nightmare scenario, but something is moving on the layer of metadata. So maybe in metadata management, we are not the more clever ones in the IT field, but slowly we copy the good idea that come from other field of IT, and something is improving.
Right, again, yeah. And so far we have covered data, we talk about metadata. There is still one last piece we have to put in the picture and that we haven't touched yet, and it is the last one. It is knowledge, And I mean and I think that this is often the most overlooked part of the whole picture. Not because it's not important, but because usually it tends to stay implicit, and it is often in the minds of the people that are working of the data scattered across stream. It doesn't always get formalized or shared in a structured way. Again, I asked Gabriele, what are the problems and the nightmares in managing the knowledge in organization? What are you seeing now in the organization and in our customers?
Yes, the knowledge management is an even worse state than the other two layers. Most we see are knowledge catalogs where you have just a flat list of terms, no relationship, no formal definitions, and so on. It's extremely difficult to involve business teams. First, because they don't see the immediate value of this activity. And second, because there is a lot of manual work to put into this, because you can't automate knowledge capture the way you do metadata harvesting, So it is even worse than the metadata harvesting definition in place. You have to put effort also to maintain those definitions, reviews them, and if you don't do so, you have a static glossary that nobody maintains, and it becomes
and again, in our recent trend, I think that is always a matter of distributing the correct responsibilities at the right moment during the development. But in this last year, we are seeing more and more chat and chattery about semantic layers, about structured ways of managing knowledge, ontology, and so on. Maybe that is driven by all the hype about generative AI and so on. But I think that is there is at least organization are trying to do something about that. And so the next question I would ask to Andrea is. What do we mean when we are talking about semantic layer or organizing knowledge in a smarter way? And if it is always a matter of responsibilities as well as a matter of how do we package knowledge and how would we do distribute knowledge inside the organization?
Yes, actually, probably semantic layer would be a good argument for another episode, because the term semantic layer is used in multiple places with different meanings, so it requires work of disambiguation by its own. But let's talk just about the ontology part, the concept of semantics. Of course, as we have said, in the knowledge level, we need to make explicit the knowledge that is implicit in the mind of all the employee of a company to describe how the company works and what are the important information to understand the context in which, the domain in which the company works. And a way to do this is the ontology. The ontology is something that you can build upon the glossary. So the glossary, you have a flat list of terms, and when you search in the glossary, you search for string. It's information retrieval. So you have all your important terms with supposedly clear definition, and then you can search like in the search engine, search by string, find the term that you are interested in, and then find out the definition, understand the meaning of the term. An ontology is basically a composition of concepts. So some terms represent concept. For example, the terms customer is a concept. A concept have different properties. So for example, the concept customer have name, surname, address, and all these properties are by themselves terms that could be defined in the glossary, in the underlying glossary. And the most important part is the fact that concepts are linked to predicate with relationship. So a customer is a person that buy a product, that make a payment, and all these are relation between the concept of customer, the customer payment, the concept of customer, and the concept of product. So the customer buy a product. Buy is a predicate that connect the customer to the product. And so basically the ontology can be seen as a graph of connected entity. And this is very important because where in the vocabulary, in the glossary, I can just search for string. In the ontology, I can move concept from concept, navigating the relationship that connect concepts. So I can search for things, not from strings. I can move from one concept to another concept and make more complex type of reasoning about the context in which I work in. This can be called a semantic layer because it's a business representation, conceptualization on my domain, and I can query this ontology to search for data. Then when I find the data, when I find the concepts that are important to answer my question, I can drill down and start to search into data. But this semantic layer creates a layer of this knowledge model that can be called semantic layer, create a knowledge of the couplement between the business user, the user outside the system, and the underlying data, making possible to search for data within the ontology, semantically rich model. And then when I found the concept that I'm interested in, drill down and search into data.
Yeah, thank you, Andrea. And so far, we are talking about these three different layers. So we have seen the layer of ontologies or the concepts that are interconnected. We are talking about metadata, and so even there we have a layer of interconnected entities with lineage dependencies and so on. And for sure we are talking also about data. But Andrea, these three different layers that we are talking about are connected with each other.
So basically, this is a very important question. We do not want to have two separated models. Basically, the model that represent data and metadata on one side, and the ontology, so the model that represent knowledge on the other side. We want to have a connection between these two worlds because I said before, we want that when we search for data into the ontology and we have found the concept we are interested in, we want to drill down. So to find all the data sources that contain instances of that specific context I'm interested in. In order to do this drill down, it's important to have a connection between the data set or the data product that expose the relevant data set and the concept in the ontology. This is what we call the semantic linking. So have a link that say, okay, this data set basically contain instances of this specific concept defined in my ontology. Or in the other way around, this concept in the ontology is instantiated by this list of data set that are delivered, exposed by these data products. Having this link make possible to navigate from the conceptual world to the physical data world, and also the other direction. So from a specific data set, moving to the concept that the row in the data set are instance of. So when I see a data set, I can ask myself what is the meaning, and I can navigate vertically up to the concept and try to understand the meaning of the data contained into the data set. Or when I found a concept that I'm interested interested in, I can discover very easily all the data set that contain that specific type of data. In this way, we create a unified model that can be navigated vertically to this vertical lineage, moving from data to concept and from concept to data.
And actually, we are still missing a piece in the journey to build this unified model of the enterprise architecture, and the missing piece is about responsibilities. So we have talked about the data, the information layer, and we're talking about the concept of shifting left those responsibilities to the development team and earlier in the life cycles of the in the life cycle of the data product. But what actually really happens and how it works in the moment that we put into place also the maintenance and the construction of those ontologies and all that semantic linking that happens between the different data asset and the knowledge models.
Yes, when you move from a list to a connected knowledge graph, you basically need two ownership models. A centralized model where a small dedicated team owns the corporate-wide ontology. They must define the core concept, attributes, and relationship. And those must stay consistent across all the organization. And also, you have a distributed linking where for each data product, the data product owner becomes the responsible for publishing and maintaining its own semantic links. So in this way, you have a central team that guarantees consistency, while you have, on the other hand, you have data product teams that ensure relevance and freshness of the linking.
Okay, so actually, practically, we are saying that the linking is done during the shift left phase of managing the data as a product, while the knowledge has to be treated as a product itself, orchestrated by or a centralized modeling team or something more federated and distributed in the organization. And that actually is the work to build and to create a sustainable model like this. But with all these efforts, my next question is, what do you get out of investing in this scenario, in managing data, metadata, and knowledge as a product? And I would ask this to Andrea.
Yes, basically in last couple of years, at least, we have invested a lot in R&D, both on the product side and on the consultancy side, on knowledge management. And we did this not because just because we like do knowledge modeling, but for a specific reason. At the least, at the origin, we have a very specific reason. And the reason was that at the time we were working with a lot of customers that were applying the paradigm of managing that as a product, and we realized that even our most successful customers, the ones that basically have created a big library of data product, following all the best practices, putting together the right operating model, basically were failing to keep the promises of this kind of approach, the foundational promises of this kind of approaches, federated and based on managing that as the product. That is the fact that over time, in the short time is not possible, but in the middle time, you can create a library of reusable component, and so new use cases can be built by combining this reusable component, the data product, no? Basically reducing in a very important way the cost of integration, because you have not to do integration anymore. You can just do composition, reusing your already existing data products, and also plateauing the cost of maintenance, because the library of data product is not something that grew indefinitely with all the new use cases, but you can start to do a lot of reuse of the already existing data products. So the dimension is not something that grow indefinitely. At some point, point when you have mapped all your critical assets, there is a big chance that you can reuse this data product that you already have implemented in the past for previous use cases. But they were failing to keep these promises because we have observed that basically the rate of reusability and composability of data product that they have implemented across domain was between 0 and 1, so very small percentage. There were not reused, actually, not reused outside of the domain. So we start to ask us why. We find out that even if the data product were of very good quality and were very easily integrable on the technical level, they were not interoperable at the semantic level because each domain within a company speaks its own specific language, is ubiquitous language. So basically, the way of modeling data, the way of representing data, the meaning given to the same piece of data in different domains is very different. And when one domain wants to use the data exposed by a data product from another domain, the first thing that I have to do is do the translation. But the translation is complex, takes time. In almost 100% of the case, the domain that need to consume the data from another domain, instead to do this translation, prefer or find more simple to recreate a similar data product with the data that they need, modeled from scratch using its own language. So we ask how we can make the product even interoperable at the semantic level, how we can make more easy to reuse a data product of another domain instead to re-implement it. And we came across the concept of knowledge modeling, ontology, of course, because as Gabriele had said, the ontology is defined at the corporate level. So try to define at the corporate level a common language to give some common definition of the most important object and relationship between object. And in this way, when a data product semantically link its data with a concept in the central ontology, basically already say how to translate in a common language the meaning of the data that it's exposing. And so this basically make not anymore necessary for the consumer to do this translation work because can refer to the common language defined at the enterprise level, can easily understand the meaning without doing translation of the data that comes from another domain and compose this data to the data of its own data product in order to support the desired use cases. So we arrive because we had a problem. We start from the problem. The problem was we have not reusability of data product across domain, and we think that having a common language and a common ontology that make data product semantically interoperable, not only technically interoperable, was the answer to make more easy to create this possibility of recomposition instead to have the situation in which is preferred to do replication instead of composition.
Yeah, thank you, Andrea. And of course, I have to do one last question about that. We haven't talked yet about AI. Nowadays, we can communicate without putting AI, the AI keyword in place. We are talking about knowledge, we're talking about ontologies. Actually, all we know that this kind of topics comes out from that kind of the kind of topic, the kind of experimentation. Andrea took more data engineering, data engineering vision about ontology, and now I'm asking Gabriele, which you are in the field, if there are some advantages and which is the connection between all the things we said with generative AI.
Yes, Jacopo. In the context of AI, context is non-negotiable for any initiative. This is because, yes, you can feed a large amount of data to a single model, but without the precise contextual signals, the result will be noisy or even misleading. But it's not just about the machine. Also, humans get overwhelmed by unstructured data and the data that don't have context. So a well-structured knowledge layer acts like a compass guiding both AI agents and analysts to get the right insight in this field.
Okay,
Yes.
so
Sorry, Jacopo, to return to the
yeah.
initial example, if you give to a large language model the number 35 and say, suggest me what to do today, it's very difficult. No matter how intelligent it is the large language model, without the right context to understand what is 35, probably it just answer me, you can sum it with 5 and you obtain this number, but it's just a pure hallucination. So you need to say 35 is the temperature today in Milan and give all the context. And so it can suggest, okay, maybe you can stay at home, not commute to work, and turn on the air conditioning. That's a good suggestion, but you have to provide the context. Otherwise, even the large language model, no matter how intelligent it is, cannot come out from this situation and missing context.
It's all right. So since now we have had enough chattery about enterprise information architecture, but let's starting about what we do to help our customers and organization that are trying to build this kind of vision with this kind of approach. So Gabriele, I ask you if you can show us something and tell us about what you do to help our customer.
Yes. So starting from the traditional data catalog, we have set up this demo with an example of a retail organization. In the data catalog, we capture the main metadata about physical systems and physical assets. In the system section, you can see the main data asset of this organization, like an enterprise data warehouse or an event streaming platform. If we drill down, like in a single system, we can see what we call physical entities. And in this case, physical entities are tables and views of this data warehouse. Also, if we step up, this is the traditional data catalog. Also, we offer data product as a first-class citizen. So we have a data product catalog. We can see that those data products are divided by domains. So we have a logistic domain, online domain, store domain. All this data catalog, all these products can be viewed by their dependencies. So in this graph, we find on the left the system that we saw before. On the center, we saw source aligned data product that reads and extrapolate data from these systems. And on the right, we find like one data product that is a consumer aligned data product that consumes informations from other data products. If we drill down in the single data product, we can see like the detail page with all the information like about the stock data product. With its also with its dependencies, the responsibilities, and all the port that it exposes.
Yeah, so Gabriele, this is what we call the information layer. So the layer that handles the information, the metadata, and so on. And I know we will have a dedicated episode about the knowledge layer, but can you give us just a taste of what's happening up there?
Yes, on the knowledge layer, we have a concept catalog, like a classic concept catalog. In fact, you can see all the concept and their related domains. But if we step into the graphical editor, we can see the knowledge graph itself. So, for example, in the case of the stock concept, we can see like what Andrea was saying, like the single concept and its relationship with other concepts like stock variation or also the site of where the stock resides.
Yeah, that's really is just like another perspective about the same data. We have seen the graph before with technical
Yes.
dependencies between data products. Here, in some sense, we are seeing the semantical dependencies between concept. And can you show and tell us how these two apparently different layers are connected together?
Yes, they are connected together, but by what we already discussed, by the semantic linking. So if we go in the section of linked data of the concept stock, we can find that it's linked with physical entities or table of like the table of the data warehouse, and also it's directly linked to the product stock. So here you can see the semantic linking between the physical layer and the conceptual layer.
Yeah, and also about that, you're talking about data product instead of Blindata. Is it a necessity? Is it mandatory to manage data as a product or not? Because obviously, not all the organization are data mesh or data product oriented.
Yes, it's not mandatory, but it's advised because it put a stronger constraint on responsibilities and also on composabilities. So we advise for this approach, but it's not mandatory.
Not mandatory because at the end of the day, the concept to the semantic link are connected with the physical data asset, not to the product, are only indirectly connected to the product because the product serve the data asset. But if you remove the data product from the equation, so you have not anymore the unit of management and serving of that data asset, your knowledge graph remain consistent because you have concept and concept point to semantic linking to data asset. Of course, you have not in the middle this application that take care of the physical asset and serve the physical asset to the end consumer and with the accountability that guarantee quality and all the good stuff that Gabriele said, but it's not strictly necessary.
All right, thank you, Andrea. And I think that at this point we have said all the what we wanted to said. So I think that it is just the time to wrap up. We covered a lot. We covered a lot very fast. We talked about data, metadata, and knowledge. In our mind, in the next episodes, we will take every this topic and drill down in particular details, and we will talk about how Blindata helps and what are also the approaches. Because of course, Blindata is a tool to help to put in place some processes and tools obviously may differ according to different contexts. So we will go in deeper details in every aspect of our vision. So if Andrea and Gabriele, you have nothing to add, I will start to thank you, Andrea, and thank you, Gabriele, for joining. And of course, thank you everyone for listening. If you like this episode, follow us, follow the podcast, and stay with us for the next one.
Thank you. Bye, everybody. Thank you.
Bye.
Bye. That's it for today's episode of InContext. We hope this gave you a clearer understanding of why enterprise information architectures and context matter more than ever. Thanks to Andrea and Gabriele for joining. Don't forget to subscribe, follow us on Spotify and YouTube, and visit our landing page for updates and bonus content. Until next time, stay curious and remember always to keep things in context.